This has introduced the DSP4 linked-in manometers for data measurement and controlled keyless data entry directly onto Excel sheets. Here are 10 reasons why you should be interested in this. The manometer provides accurate data measurement. There is no hand entry of measured data. In other words, you do not have to stop to enter data. You just press the sample switch. That eliminates keying errors in the event that you are in the habit of keying in your data into Excel sheets. If you handwrite, it eliminates illegible handwritten entries. And it also eliminates number reversal, dyslexia, which is the common word for number reversals. And that can happen whether you write it by hand or whether you key it in to the Excel sheet. Now, the technical balancer's data gathering routine is unbroken, saving time, meaning that he doesn't have to stop and enter data. He just goes on from measurement to measurement to measurement, just putting it in with a click of the sample switch. Now, the Excel sheet is the immediate foreground record. Now, what does that mean? That means that that is the record. You don't have to download it or any data to it. If you download the Excel sheet, that is the record. Excel sheet records support quantum merit. In any law situation, if the Excel sheet is signed by the balancer and the supervisor, that makes it okay to enter as evidence, whether you're trying to get paid or whether you're trying to prove to somebody that you did the work. Now, a supervisor can review the record in the field with the balancer, meaning the Excel sheet with the balancer, in real time using TeamViewer or an equivalent application. So if the balancer has a problem and he wants the supervisor to look at it, he can in the field. Or the supervisor may just want to look at the record in the field, and he can do that with the same thing. Now, Excel records are instantly savable and transportable. And that's important in today's electronic world. All right, that's a brief outline of why this is something that you should be interested in, because it saves you time, it saves you money, and it gives you permanent records. So thank you for listening, and we'll be back shortly with a little video on how this actually works with Excel. Thank you. All right, now in this part of the video, we're going to show you a couple of the components that make up the DSP4 linked-in manometer system for data measurement and controlled keyless data entry. What you're looking at right now is a tablet which has Excel on it. So that's one component, and most people have tablets, and but that's one of the components of the system. We don't supply that. We presume that you have it or can get it. But we do supply the Excel and the programs necessary. Now I'm going to go over to look at the manometer. And there you see the DSP4 manometer. It measures differential pressure once a second. It measures temperature once a second. It converts the differential pressure to flow in feet per minute once a second. It has Bluetooth, and it transmits that data once a second into the air. The transmitted data is collected by or received by the tablet, and the only thing that is saved is the data saved when you use the sample switch, which we now are taking a look at. So the three essential components. There's the manometer, there's the sample switch, and it's a two-sided sample switch. That's why we call it an RKR. It's a rocker switch. One side, when you press, you get an array number, a whole number, and if you press the other side, you get an average number. But we'll go over that a little bit later. So now let's go on to look at the tablet a little bit and kind of zoom in as much as we can on the tablet. And what this is a simulated flow hood measurement. There are 4 ducts that we're looking at, and we have shown them here, and that's how this tablet is arranged. It's pre-arranged so that you can find a place when you're taking measurements to put the data in. So in this simulated example, there are 4 registers, and there are 4 suggested values for air flowing through. One is 170, 180, 175, 170, with a total of 695 feet per minute. So that's the target that we're trying to get to. So we'll come back to that and start that up as soon as I get to the next part of the video. Okay, we're back and we're ready to show you how the recording system works. I'm going to use a stylus so that you'll be able to see more. But at any rate, what you're looking at is a kind of a pre-designed Excel sheet. You don't have to do that. You could just go with a plain Excel sheet. But we think that it would be a little more illustrative if we had something that's pre-planned. All right, so you have to imagine that there is a balancer out there with a hood. And what he's trying to do, he's trying to balance the air through this hallway, let us say, with registers. We call them 10, 20, 30, and 40. So the first thing you have to imagine is he's got a hood, and he goes to the first register, which is 10, and he puts it in place. Now he has the tablet actually on the hood, or if not on the hood, let's say on the trolley that the hood may be on, if you have one of those. But the first thing he does, he touches the cell that he wants that first to go to, right there. Now, the tablet knows where the data is going to be acquired at, and to acquire it, you go to the Acquire with Rocker Switch button. Now, he's ready. He puts the hood in place, and when he's ready, he presses this array button because he wants a whole number in there. And there's the number. And then it drops down automatically, so he doesn't have to do anything except walk over to the next ceiling register, which would be 20. And when he's in place, he holds it up, he's ready, he presses the button, and there's the answer right there, the whole number. All right, he goes to the next and third register, number 30, puts the hood up. When he's ready, he presses the button, and there's the number. He goes to the 4th register, number 40, and he puts that up. Ready? He presses the button, and there's the reading. Now, notice, you have to visualize he just walks from one to the other and hoists that hood up and just takes that reading. There's no break in his measuring routine. He doesn't have to stop. It's all there. Now, when you're balancing, obviously, having that record in front of you is very important, because when you make your adjustments at the VAV box or wherever you make them, if you have another column which you can use simply by touching the top cell to the right of 97, the 97 value, you can make your adjustments and then go back and do it again and see how you have adjusted, what the effect is on each one of the ceiling registers, right? So balancing, you often have to go back several times, but this gives you a record that you can see. Now, when you're all finished with this, you can save this, and this shows the work was done. It shows in detail what has happened while you were doing this. Well, I think that's a pretty good description of how this thing works, and we'll have another video shortly with a picture that shows you how the air hood is arranged to carry the tablet. All right, thank you, and we'll see you again soon. This is a picture of the flow hood that we had discussed before. Here are the features. It has a tablet mounted right in a frame. So this tablet is removable, but when you're using it, you put it right in the frame there. This is the DSP4 manometer, and that's with the button on top is the sample switch. The weight of this with the tablet and the DSP4 manometer is less than the hood, which is a fairly heavy hood, and it is obviously a short ridge. But as I say, the tablet and the DSP4 and the hood weighs less than with the short ridge meter only attached. May seem difficult to believe, but it's true. The tablet and the DSP4 manometer is not as, that combination is not as heavy as the short ridge. And that's obviously a short ridge hood. So that adapts pretty well, and you can do the same thing with any hood. We just wanted you to see the hood that we were contemplating using in our last video. All right? So thanks again. We'll see you later.